Right, let's have a look here. So what have we got? A racing car covers a journey of 8.8 kilometers from rest to rest. Okay, so let's get our graph going. So this is time in seconds, and this is velocity in meters per second. Okay. It accelerates uniformly in the first minute to reach a max speed of 40. So that point there on the time axis is 60. And then that matches up with a 40 here. It holds the speed for some time and then slows uniformly to rest with a deceleration 3 times that of the acceleration. So acceleration is rise over run. 40 over 60 is 4 over 6, which is 2 over 3 meters per second squared. It continues at this for some time. So we'll mark this, we'll call this here t. So this point here will be 60 plus t. And then decelerates with 3 times the magnitude. So that would be at minus 2 meters per second squared here. Okay. I suppose maybe we'll call that T1. And we could call this T2 here. So that would be 60 plus T1 plus T2. Okay. And we have to find the times, right? And we also know the total distance is 8,800 meters, it's 8.8 kilometers. So we have enough info here to work out the area in the first piece. So maybe I'll just use a different color there. So this area here is going to be a half the base by the height. This area here is going to be the base, which is T1, by the height, which is also 40. And this area here is going to be a half 40 times T2. So that one is 20 T2. That one there is 40 T1. And that one is 30 times 40, 1200. And those 3 must add up to 8,800. So that's like our first equation of T1 and T2. Well, let's clean that up a bit. Cancel, 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 cancel. Divide by 2, so I get 2T1 plus T2 will equal, that would be 440, and that would be 60. So 440 minus 60 is 380, isn't it? Okay, so this obviously is going to be a smaller time than the 60. So if I just kind of S80, yeah, so maybe this is like a minute and a half or something. Okay, so let's see, we need a second equation. Now, let's see. We know that actually the T2, it's possible to figure out the T2 from this triangle. I just zoom in on it. You know the slope here is minus 2, which means you go out 1 unit and you go down 2 units. So if this quote here is 1 unit and this is like 2 units, so the height is twice as big as the base. The height is 40, so that means the base should be 20. So let's test it out here. The slope will be minus 40 because you drop 40 over 20, which indeed is minus 2. So actually Our second equation, if that's like our first equation, our second equation is just T2 equals 20. It's not really an equation, it's actually a solution. So if T2 is 20 and I sub that in, I get 2T1 plus 20 equals 380. So that means 2T1 equals 360. So T1 equals 180 seconds. So the question was, what's the total time? So that's 60 plus 20, that's the T2, plus the T1, that's 180. So 180 and 20 is 200, 260 seconds. That's, what's that, 40 seconds short of 5 minutes, isn't it? So that's 4 minutes and 20 seconds, I think. Right. If the maximum speed over the final kilometer, if the maximum speed over the final kilometer of the journey had been restricted to 20, show that the time taken from rest to rest would have been at least 22.5 seconds longer. All accelerations and decelerations are the same. Okay, so this one now, that's interesting. Time in seconds, velocity in meters per second. So velocity in meters per second. Okay, so the only difference here is the addition of a speed limit for the final kilometer. So what will happen is the car will accelerate up in the one would imagine still the first 60 seconds up to 40, because this distance here, we worked it out, is 1200 meters, 1200. So that's still a long way away from the final kilometer. It'll continue for some time at a constant speed, but at some point it needs to begin braking. I imagine as late as possible, so that it just about hits the 20 for the last kilometer. And it also has to get to rest as well, doesn't it? So it's actually, it might be the case that it's more like this actually. It has to, for the last kilometer, it has to brake down to brake until it reaches 20, but unfortunately it might find itself having to travel at 20 and then hit the brakes to get to rest at the end. I think it'll be more like this actually. So we know that this whole piece here, this whole piece is 1,000. Right, okay. Now this acceleration here is still 3/2 meters per second squared, and this one here is still -2 meters per second squared, and this one's -2 meters per second squared. Right, so let's start putting in some times here. This is 20, and again, because the slope is -2, this is 40, so we could actually work out this length. -2 means you go out 1 and you go down 2, so again the height has to be twice as much as the base. It's gone from 40 to 20, so this distance here is 20, so that means that there is 10 seconds. So we have that, that's good. Okay, what else could we work out? Well, since we know this is 10 seconds, we might as well get this area so we can start totaling things up. So this area in here, you have your rectangle, so that's 10 times 20, and I never actually marked in the 20 here. That's plus a half 10 by 20 as well. So that's 100, and that's 200. So that's 300 meters. So currently we're at 1500. Okay. Now if that's 1,000, now we're at 2,500. So we have 1200 plus 300 plus 1000. So 300, 2500, like I said. Switch back to black. So therefore, I'll need to do 8,800 minus 2,500. 6,300. So that means this here is 6,300 meters. And again, that height is 40. So if I divide this by 40, I can get the base. So let me just do that on the side. 6,300 over 40. Cancel, cancel. So what's that? That's 315 over 2. So that's 157.5. Well, that's how the 0.5 comes into the question, I guess. So here to here is 157.5. Good. So we only have this little piece left to do here. That height is 20. Okay, so that's a 20. Right, so we should concentrate on this piece now. If we call this x, well, let's see, what can I know? I know the whole thing's 1,000. I don't know the time for it. Oh, actually, I know the slope here is -2, and if that's 20, then this here, this is 10. Okay, so I'll call that x. So now we have 20 times x, that's the rectangular piece, the height of 20 times x, the base, plus a half 10 times 20, that should equal 1,000. So that's 100 there, and that's 20x plus 100 has to equal 1,000. So that means 20x has to equal 900. So that means x has to equal 45. So the total time now is 60 plus 157.5 plus 10 plus 45 plus 10. So 45, 55, 65, and 60 is 125 plus 157.5. So 125 and 125 is 250, 277.5. Is that right in my head? 277.5. Must have added it up wrong. Let's just do this on the side carefully. 125 plus 157.5. So that's 0.5. That's a 12. 5, 6, 7, 8. And that's a 2. And then I'll have to minus the answer I got earlier, which is 260. This is looking promising. Minus 260. And that leaves me with 22.5 seconds. So that's how much longer the journey is with the speed limit. It's 22.5 seconds longer. This is nice because it confirms that what we must have done earlier must have been right, because our time here for the second half is 22.5 seconds longer than the first. Now it's possible that we made some mistake, and the mistake was such that the difference between the two answers is still 22.5, but the two answers are wrong. Not likely, but it's possible. But the fact that I got 22.5 here, that's reassuring. Yeah, okay, so that's everything for question 1 here.